Okay, it's a circle, and center obviously C is 5 and it's -2, and the radius, as r squared is 25, so radius equals the square root of 25, which equals 5, but it asks me for the length of the diameter, therefore diameter equals 10. Part 2. Find the equation of the line which passes through C and the point 72. I'm always going to draw a sketch of these. Sometimes it helps. It very rarely hinders. Centre is 5 -2, so go across 5 down 2. Radius is 5. Well, that's 5 -2. And the radius is 5. It will just touch this point here. That might be important. Go something like that. Ooh. Right. And 7, 2, well, 7 can't be far across, and 2 is going to be, I think it's going to be about there, according to my little graph here. And I've got, that's C, and point P is 7, 2. Equation of the line which goes through there. Well, I want to find the gradient of that, so I'm going to put it onto here. And how far up does it go? It goes up from -2 to 2, goes up by 4. And it goes from 5 to 7, that goes across by 2. So I'll know immediately that the gradient equals change in y, which equals 4 over change in x, which is 2. So gradient is 2. So y equals 2x plus c. And I need to sub in any point. So I'm going to substitute in 7, 2, because it's got no negatives in that. Don't forget the first one's x, the second one's y. I always write that down to save myself making that mistake. So y is 2, 2 equals 2 7s, that's 14 plus c. So c equals -12. And so I get y equals 2x minus 12. That's my answer. And for the line, and I can see that the y-intercept indeed could easily be -12. So it could be true. So I've done part of that. Calculate the length of CP. Okay, length of CP. This is part 3. Well, I can see it from here. It's that length there. Equals the square root of, well, I've got 2 and 4, so it's going to be square root of 2 squared plus 4 squared, which equals the square root of 4 plus 16. That's 20. Might want me to give it exactly. So that's 24 goes into that. So 4 times 5, which is square root of 4 times the square root of 5, which equals 2 root 5. And I've got to determine whether it lies inside or outside the circle. From my diagram, it looks like it's inside. And the radius is 25, and root 20 is less than root 25. Therefore, P is inside the circle. Need to put a few little arguments like that down. And finally, part 4. Determine algebraically whether the line with that meets the circle. It's got parallel, goes through there. Does that meet the circle? I'll try to do it roughly to scale. It looks like it probably doesn't. We'll see. So for this, we have to solve them simultaneously equations. So I get x minus 5 squared plus y plus 2 squared equals 25, and y equals 2x. Have to do it by substitution, so I'm going to substitute y as 2x, and that gives me x minus 5 squared plus 2x plus 2 squared equals 25. Square that, that's nice and easy. X squared minus 5x minus another 5x is minus 10x plus 25. And this bit plus, I'm going to do it over here because the sort of thing I will make mistakes with. I know myself a little bit too well. That'll be 4x squared plus 4x plus another 4x, will be plus 8x, and then plus 4, and that equals 25. Quadratic equation always getting equaling 0, so I've got 5x squareds there, minus 10x plus 8x will be minus 2x, and 25, I'll take away the 25, so I end up getting plus 4 equaling 0. So that's my equation. And if it find out whether it meets, it doesn't say where, what I need to do is look at discriminant. So b squared minus 4ac equals b is negative 2 squared minus 4 times a is 5 times c is 4, which equals 4 minus 80, which equals negative 76. And negative 76 is less than 0, therefore no solution to the quadratic. Therefore y equals 2x does not meet the circle. And I still think it's always worthwhile drawing a little picture. Try and do it roughly to scale. And that's question 10 and the whole paper done.